While developing the game, there were many times I wanted to know how much time it took to execute certain sections of code. This is called code profiling, and it has many uses. Figuring out exactly what parts of code are causing bottlenecks, comparing different implementations, seeing how code performs on different platforms. You need to be able to measure, to have actual numbers you can compare, not just a fuzzy feeling like this seems slower. If you can't measure it, you're not actually doing science. There are quite a few different ways to profile code, but I ended up making my own custom solution. It took some time, but it does exactly what I want it to do and was an excellent learning experience. It's actually very simple to measure how long it takes to execute a specific section of code. All you need is a high-resolution timer. I use a timer routine from the Allegro library, al-get-time, which typically has a resolution in the order of microseconds. I record the time before and after the code I am profiling. This works great. But then, what do I do with the value? Print it to the console? I'm a big fan of debugging by printing to the console, but in this case, it's not a good fit. First of all, printing to the console takes time, enough time that it can affect what I am trying to measure. Second of all, I'm usually trying to measure things that happen every frame. So if I print it to the console, I would have 40 lines per second to look through. What I do instead is to use my logging system to log the profiling information. The log exists in RAM, so adding text to it is extremely fast compared to printing to the console. Then when the game exits, the log is saved to disk. This is an excerpt of the log file. The elapsed time is multiplied by 1000 to reduce the number of leading zeros, so the units of time are milliseconds. It took 0.0059 milliseconds on frame 8 and 0.0061 milliseconds on frame 9. Or in other units, it took 5.9 microseconds on frame 8 and 6.1 microseconds on frame 9. The game runs at 40 FPS or 40 Hz, and the reciprocal of that is 25 milliseconds. That's the total amount of time each frame has to execute. So this particular function that only takes 6 microseconds is a very small portion of that, 0.024%. Manually looking through log files is slow and boring, so I made a graphical way of viewing the data. It reads the log file with profiling log entries and builds a graph. The x-axis is the frame number. The y-axis is the profile time. I can profile multiple things and have them all show on the same graph. Let's go through an example. This is the code I want to profile. How long it takes to draw the screen overlay, and how long it takes to draw individual parts of it. Start the game and open Settings. Check Advanced and Debug. Go to the Log tab and change the logging group to Profile. Check the box to make Log Timer Screen Overlay log to File. Check Save Log on Level Quit. Then start a game by clicking Start Single Player Game. Let it run for a few seconds, then quit the game with Escape. Click Open Most Recent Profile Graph. There you will see the data we just collected. This is the total time it took to draw the screen overlay. This is how long it took to draw the top frame text, the bottom frame text, and the actual frame. These values are all in the microseconds, so there are no issues here. Move the plot by clicking and dragging. Resize with the mouse wheel. Turn on and off series by clicking on the legend. Shift-click and drag to zoom to a specific area. To access the menu, right-click and hold, then select a menu item, then release the mouse button. Here, I will auto-range the entire graph. Here, I will lock the y-axis so that zooming only affects the x-axis. Quit the graph with Escape. Now let's try an experiment where we also print the log entries to the console to see how that affects our measurements. Check the Print to Console box. Run the game for a few seconds, then open the most recent profile graph. Now the total time is over 2 milliseconds. That is huge. The individual tasks seem to be measuring properly, but they do not add up to the total. The issue is that printing the log entries to the console takes a huge amount of time relative to what we are measuring. The individual tasks are not affected because the initial time and measure time do not include the log entry, but the total time includes 3 log entries. Now let's look at some other things we can profile. Reloading bitmaps. If the display is resized or changed, bitmaps stored in GPU memory are lost and need to be restored. Rather than reloading them from disk, I keep a copy in RAM so I can restore them faster. I need to measure how long it takes so I can make it as fast as possible. This is the code where the bitmaps are created. These are the regular tile bitmaps stored in video RAM. These are the copies stored in normal RAM. This is the code where they are loaded from disk. They are loaded into video bitmaps, then copied to memory bitmaps. Both creation and loading are only ever done at the program start. This is the code where the bitmaps are restored after a display change. I copy the memory bitmaps to the video bitmaps. I profile the entire function and the individual subsections. So let's run the code and do some profiling. Select Log Timer Rebuild Bitmaps. Start the game. Toggle full screen a few times. Then view the profile graph. This is how long the entire process takes. This is how long the rebuild tiles takes. This is how long it takes to rebuild level icons. This was done on a Windows 10 machine with a Ryzen 5 5600X and an RTX 4060. Now let's try it on some different hardware to compare. This was from an Ubuntu 20.04 machine with an i7 4770 and a Radeon 520. This was from a Windows 7 machine with an Intel Core 2 T5500 and an Intel 945 GPU. As you can see, it takes considerably longer on this older hardware. Over half a second. Even at its best, it takes a few frames. Because it only runs when the display is changed, this large delay is acceptable. The user will accept this small hiccup or delay if the only time it occurs is when they adjust the screen size. Still, I do everything I can to minimize it. I realized the level icons are only used in level 1, the overworld level. So I modified my code so they only get rebuilt when the current level is 1. These are the same profiling results, but in level 2, when rebuilding the level icons are skipped. I was able to reduce the total time from 40 to 60%. This is an almost imperceptible change, but I can measure it and see how effective it was.